Until now, we've managed quite well to solve systems of two equations. But now we're going to throw in an extra variable and an extra equation. So how can we solve this system of three equations? We have 1, 2, 3 equations, and each equation has 3 variables. We have x, y, and z. And we need to find a way that we can systematically eliminate variables in order to determine what the variables are. So how do we do that? We can use what we've already learned about solving a system of just 2 equations to solve a system of 3 equations. Essentially, it's like a puzzle of elimination down to the last variable. The first thing you need to do is closely examine your system of equations and use what you know about elimination, what makes it easy to eliminate a variable based on coefficients and signs of those coefficients, and determine which one would be the easiest to eliminate. Usually it'll stand out to you, but if not, you can figure it out. In this case, I'm going to look at my equations and see which one appears to be the easiest to eliminate. In this system, I think I'll start by getting rid of the y's. Why might I have chosen the y's? If I look at my y's, I see that 2 of my y's already have a similar coefficient of 2. They're both positives, but I could make one of them negative, and that would be easy to get rid of. So that's why I chose y. I could have chosen z, or I could have chosen x. It doesn't really matter. I just decided I wanted to choose y because I could already see that they both had coefficients of 2, and I was thinking ahead, and I knew that they would be easy to get rid of. Now that we've decided which variable we're going to eliminate, in this case, the y, you have 2 tasks ahead of you. One is to make 2 pairs of equations out of your 3 equations, and 2, eliminate the same variable from each pair. That same variable is the y that you've decided to eliminate. So ultimately, these are the keys to breaking down a 3-variable system into manageable parts. The keys are making 2 pairs of equations from your 3 equations and eliminating the same variable from each pair. That is the new task that you are going to learn to do in this video. So, let's go ahead and make our pairs and eliminate the y that we've decided to eliminate. So I'm going to pick my first pair of equations and I'm going to eliminate the y from that pair of equations. My first pair of equations that I'm going to use, let's use the 8x minus y plus 2z equals negative 19, and the x plus 2y minus z equals 1. And while we're doing that, we don't need that equation at all. We can just forget about it. Let's make ourselves some more room here. And let's eliminate the y. We know how to eliminate a variable when we need to get rid of it, right? We just need to be able to add so that the coefficients go away. In this case, we already have a positive and a negative. The problem is we don't have the same coefficient, but we can create the same coefficient, right? We just need to multiply our equation times a 2. If we multiply our top equation times a 2, then we're fine. We're going to get, on the top, 16x minus 2y plus 4z equals negative 38. And our bottom equation is going to stay the same. So our y values are going to cancel out, and we're going to have a new equation when we combine. Let's combine straight down and get 17x. Positive 4 and negative z gives us a positive 3z. Notice how we no longer have a y term, equals negative 37. So there's a new equation. 17x plus 3z equals negative 37. So let's just remember that equation. Let's just put a square around it and just kind of cast it aside for a little while. We don't need it for right now, okay? We're just going to remember that we have that equation. We now have a two-variable equation that no longer has a y, and that's good. We can work with two-variable equations. So now we're going to make a second pair of equations. All right, now it's time to make our second pair of equations and eliminate y from that pair of equations. So this time I am going to use this equation and this equation, and I'm going to just scoot this one up out of the way and not use it. All right, so I'm just going to keep that little reminder up there of what I'm working on. So I have these two equations and I want to eliminate my y. So my y's already both have a coefficient of 2, but they're both positive, so I need to make one of them negative, which is fine. We know how to do that. We learned how to do that. I'm just going to multiply the top equation by negative 1, which is no problem. So if I multiply the whole top equation by negative 1, I end up with a new top equation of negative x minus 2y plus z equals negative 1. And my bottom equation is 2x plus 2y minus 3z equals 1. So, just what I wanted to happen, happened. I've got opposite y values that cancel each other out. My goal was to eliminate the y's. I was successful. So if I add straight down, my x coefficient becomes 1. So I have 1x, negative 1 plus 2 gives me positive 1, 1x, and 1z plus a negative 3z gives me minus 2z, and negative 1 and positive 1 equals 0. So now I have another equation that doesn't have a y value. I have a two-variable equation, x minus 2z equals 0. So if you recall, the other equation that you made was also a two-variable equation made with the variables x and z. So you have a two-variable, two-system equation with the same two variables of x and z. So what do you think you can do with those? You can probably make a two-system equation and solve for x or z. Alright, so this is great. Now we have two equations that only have the two variables, and we can easily solve one of those equations by elimination, right? Take a look at the middle term. You have positive 3z and negative 2z. That can easily be taken care of. Even though they are not the same coefficient, they already have opposite signs. So let's just go ahead and multiply them so that they can have the same coefficient. I'm going to make them both 6. So if I multiply the top equation by 2 and the bottom equation by 3, then I will accomplish that. So multiplying the top equation by 2 and the bottom equation by 3, that gives me 34x plus 6x, or 6z, equals negative 74. And then 3x minus 6z equals 0. And look what happens. My z's cancel out, which is good. That's what we wanted. So we get 37x equal to negative 74. Now we can solve for x. X equals negative 2. Well, that's really good. Now we know that x equals negative 2. We can create another set of two equations with only two variables that we can easily solve once we take that value of x equal to -2 and plug it in. It's very simple. Remember I told you it was like a puzzle, drilling down using the skill of elimination to find out what the value of each of these variables would be. So once again, you get to pick which two equations you want to use. You can plug the -2 in for x into either of the equations. It doesn't matter. I think that I will pick this equation and this equation and plug my -2 into those. So if I put -2 in for x in those two equations and then solve, I will be left with y and z as my only two variables in the equation. I'm then able to solve by elimination for one of the variables y or z. When I plug those in, it's just a matter of arithmetic and finding out what I have. So, working that out, I end up in my first equation. I'm going to scoot this over so that I have a little room to work here. I end up with 2y minus z equals 3. And how did I get 3? Because I add 2 to both sides. In the bottom equation, this becomes -4. So I'm going to end up adding 4 to both sides. So this becomes 2y minus 3z equals 5. So there's my two equations. Let's go ahead and solve. How am I going to solve that for one of the variables? I can solve by elimination. I think I'll go ahead and get rid of the y's because they both have the same coefficient. I'll multiply the top equation by -1. That's going to give me -2y plus z equals -3. 2y minus 3z equals 5. My y's are going to cancel out just as I wanted. And I'm going to end up with -2z equals 2. Z equals -1. So now I know two of my variables. I know my x is -2 and I know my z is -1. I can finish solving for the last variable by plugging these two into any one of the three original equations. It doesn't matter which one. I can pick any one that I want. I'm going to choose this equation because it has the fewest or smallest coefficients to work with. And I'm going to plug in -2 for x and -1 for z. And I'm going to solve. -2 plus 2y plus 1 equals 1. And then I'm going to solve and I get -1 plus 2y equals 1. Add 1 to both sides. You get 2y equals 2. And you end up with y equals 1. So now we've discovered all three values of our variables. We know the ordered triple. We know that our values are -2, 1, and -1. We have solved the puzzle. Now it took a few minutes to do, but you get faster and faster the more you do. You try one. Remember, make two pairs of equations, eliminate the same variable from each pair. Examine this set of equations and see which variable looks like it would be the easiest to eliminate first. I'm looking at it, and I already see one of the variables that looks like it would be easy to eliminate quickly. So pause the video, see what you can do, and then restart it, because I've worked this one out on the next screen, and you can check your work and see if you come up with the same thing I do. Go ahead and see how you do. Well, let's see how you did. Did you make your two pairs? I used the first equation and the second equation to make my first pair. When I did that, I eliminated the z, and I came up with 3x minus y equals 1. And then I used the first equation again and the third equation to eliminate the z. In both cases, I was able to eliminate without any multiplication, and I came up with 4x plus 2y equals 8. Notice I have two equations that only have an x and a y. After that, I took those two equations and I was able to eliminate the y's. I had to multiply in this case. I multiplied the top equation by 2 in order to have a positive 2 and a negative 2 to eliminate. I was left with 10x equals 10, and I discovered that x equals 1. I took that value of x equal to 1 and I plugged it into my top equation, and I continued on to discover that y equals 2. Once I had x and y, I plugged back into this equation and drilled down until I figured out that z was equal to 3. Check your work against the work that I've shown here if you made a mistake and did not come up with x equals to 1, y equals to 2, and z equals to 3 to see where you went wrong, and continue to practice. Summary: when we're solving three variable systems, examine your system and decide which variable looks the easiest to eliminate first. Then make two pairs of equations from your three systems and eliminate the same variable from each pair. Continue to substitute your found values and eliminate unknown variables until you know all three variables.